All right, so here's a summary of solving quadratic equations. Quadratic equations, first of all, are any equations that whose highest exponent is a 2, and this is what they look like usually in their standard form, but they'll all have this 2 as an exponent, and it's the highest. So if you ever see that, you got yourself a polynomial with the highest exponent of 2, you call it a quadratic. Quadratic equation, a quadratic function, if it's a function, passes the vertical line test, etc. And usually we're trying to solve these, and when we try to solve a quadratic equation, we first make sure it's equal to 0. Okay? And here's our methods. First method we could use is try to graph the equation and look at the answers, because we're looking for where it crosses the x-axis. However, it's got some things that we don't like about graphing. One, it's not accurate. 2, it doesn't show if we have imaginary solutions. 3, you got to have something to graph it with, either a graphing calculator or an app of some kind, or else the internet. And so graphing, yeah, we can use it, but it's limited in what it can do and when we can use it. Factoring, we like to do the factoring. We have an entire sheet, a handout that I've given everybody on how to factor. Lots of stuff to it, so be careful. Just follow those steps and you should be able to factor any of these quadratics. And then probably the most important one out of all these, the quadratic formula, because it solves every single equation, every single quadratic. Notice up here your A, B, and C. That's the A's and the B's that they're talking about down here. Not the X's, the numbers in front of the x squared, in front of the x, and then the constant, the C, that has no variable. So if we know how to use this formula, the quadratic formula, you're going to be in great shape. And lastly is the square root method. And, we actually teach this first, but I'm not quite sure why now as I think about it, because it only works for a few types of equations. And we're going to look at those special equations today. But it works like on these quadratics. And notice in these quadratics, there is no bx in it. It means there's no linear term or no b term. And so if it's those, we can use the square root method on, and we'll see some examples of that as I go forward here. So let's look at, we're going to ignore graphing because it's not accurate. Everybody has different calculators, etc. We're going to focus on the factoring because that's a very common method, the quadratic formula, and then the square root method. Now the factoring should go in 2. Every single quadratic can be solved with this. Many can be solved with factoring. So those are our first go-to ways to solve them. Primarily factoring first, quadratic as a backup. It'll be very, very simple for us now, hopefully, because we've been practicing factoring for a long time now. So here's a quadratic. It's got 3 terms. Its a is 1. This is an easy factorization. Remember, we just go x and x, and this is your r and your s, and r times s have to equal c, or 8 in this case. That's your c value. But r plus s, they have to add up to your b value, which is 6. That's this guy. So 2 numbers that multiply to 8, and you just start making a list. It could be 1 times 8 or 2 times 3. Oops. 2 times 4, sorry. 1 times 8 and 2 times 4, they both multiply to 8, but we want the pair that add up to 6, so we're going to use the 2 and the 4. So there's our 2 factors. Okay, now some people are having a hard time understanding what all this means, so just real quick, all I've done is taken this equation in red and broken it up into the 2 binomials that, if I were to remultiply them, are equivalent to the polynomial in red. And you can see I distribute the x and I distribute this 2. And when I collect my like terms, it does indeed multiply back into the original equation. Okay, so we're just trying to unmultiply it, and that's what we've done here, and we call that unmultiplying factoring. Okay, so there's our 2 factors now, because it's x plus 2 times x plus 4, and since their product is 0, one of those factors has to equal 0, and so that's what we set the equations out to equal. And we get our 2 answers. And we're done. Now, That works great and everything. I'm going to show you now the same problem done with the quadratic formula here. Let's see if I can slide my stuff up here by turning off my camera. There we go. So I'm going to do the same problem. Let's just rewrite it here. I'm going to run that darn thing through the quadratic formula so you can see it in there once. Now this formula, we should get it memorized. It's up on the wall. I usually write it on your test, but my goodness, since it solves all of our quadratics, one equation that rules them all, we might want to know what it is. So my A here is 1, my B is 6, and my C is 8. Let's label those things so you got them. So we've got A, we've got B, and we've got C. So now it's x equals, and it's x because, see, notice this is the x in the equation, so we're solving for x. X is what? X is the opposite of b. B is 6 here, so negative of 6. Plus minus square root of, take your b value and square it. So I go 6 squared. I don't know why I wrote that in blue. There we go. Minus 4 times a times c. My a value is 1. My c value is 8. All over, extend that fraction bar, extend that radical sign, 2 times a, and my a is 1. So now our only job is to simplify this expression here. Okay, it's all numbers now, no variables left. We're just trying to clean it up. So we start underneath the radical in this area called the discriminant. And we have to do your exponent first. PEMDAS, remember. Please excuse my dear Aunt Sally. So we'll do our exponent first. So we got negative 6 plus or minus. I square my 6, that's 36. And after I do exponents, I go to multiplication. So I can do the 4 times 1 times 8. And 2 times 1 is 2. Now, I already know the answers for this thing. It better be negative 1 or negative 2 and negative 4 up there. So let's find out if it is. 36 minus 32 is 4. That's nice. 4 is a perfect square root. Square root of 4 is 2. So there's our answers. We just have to write them down now. We got negative 6 plus the 2 over 2 and negative 6 minus the 2. I'm just doing this minus here, plus the 2, and then the 1 with the minus 2. And negative 6 plus 2, that's a negative 4 over 2. Negative 2, negative 6 minus 2 is negative 8 over 2. Negative 2, negative 4, negative 2, negative 4. It's consistent. So you can use any method, either method rather, to solve that. Next one here, let's do this guy. We got, 3-term quadratic equation. I check it for a GCF, there isn't one. I check it for an X that can come out, there isn't one. I recognize the 3 terms, and I go, yeah, it's probably this. Okay, now we have a special method for this. We could start hacking away at it and go, hey, it's got to be a 3x and x, but we'll use this little trick that I've been teaching you where you just put the a term like so, the ax term like so. Okay, then we multiply these two, not those two, I missed my 5. We multiply these two, that's negative 15. This is what you want your r times s to equal. So r times s has to equal this negative 15. And you can start making your list, 1 and 15, 3 and 5. They have to add up to negative 2, so we want the 5 negative, the 3 positive, and now they add up to negative 2, and they multiply to the negative 15. So let's finish up here. We'll put in that plus 3 is minus 5. And don't forget, in this same line here, we'll divide those by 3. And so our final factorization is divided by 3, x plus 1 times 3x minus 5 equals 0. And we can now solve those. So x plus 1 equals 0. There's an answer. X is negative 1. 3x minus 5 equals 0. We'll add 5 to both sides and divide by 3. And there we go. Okay, so I solved that one by factoring, and now I'm going to do it again with the quadratic formula. Now this time I'll show you, I'm not going to do all the details. I'll talk you through it. I know my a, My b is negative 2. Be careful there. My c is negative 5. Okay, let's write those down so we don't forget them. B is 3, or a is 3, b is negative 2, c is negative 5. Now, substitution. So we go negative of negative 2. Negative 2 squared minus 4 times a, which is 3, times c, which is negative 5, all over 2 times a, 2 times 3. So there's my substitutions. There's my b squared, there's my a, my c. Let's clean this up. See, I got double negatives there, so that's going to become a positive 2. Right here, I'm squaring a negative 2. This will always be a positive when you square something, so that's a 4. I can do my multiplication. Now, this multiplication, 4 times 3 is 12, times 5 is 60. But see this double? This is like a negative 4 times a negative 5. That's going to be a positive sign. In fact, I would do negative 4 times negative 5 is 20 times 3, 60. So it's going to be plus 60 in here. Now we can do the addition inside. That's 64. Hey, 64 is a perfect square. That's an 8. And so we've got two answers here. We've got 2 plus 8 divided by 6. 2 minus 8 divided by 6. 10 over 6, or 5/3. You can see that answer right off here to the side. The other one, 2 minus 8 is negative 6 over 6. That's negative 1, and that coincides with our other solution. So we get the same answers. Point is, you can do it by factoring. By far the quickest. But if it doesn't factor, you can always use the quadratic formula because it works. It just takes a little more effort. So that's the basics of quadratics. We got a great way to solve them. Now, these exceptions look like this. Okay, here's one of the exceptions. Looks like this guy, or with numbers, something like this. I forgot my little squared there. Okay, but notice, and again, I should be putting a C there for that, because there is no B term. There's no term with just an X next to it. And these can be solved with that square root method. Real simple. All we have to do is isolate the X squared. Isolate means to get it alone. So there we go. I've isolated X squared. Then once you isolate it, and this is why it's called the square root method, you square root it, because the square root of X squared is X. But if you square root the left side, you got to do the right side. And so you get plus or minus, and we separate that fraction. All right. Square root in a negative 9. Poke out the eye. See here, square root of 9 is 3, so this is 3i over root 5. And we don't like radicals in the denominator, so we'll rationalize it. Plus or minus 3i root 5 over 5. And we are done. So this thing has two answers, and they are 3i root 5 over 5 and negative 3i root 5 over 5. Okay, so square root method, this one took a little while because we got this messy stuff over there, but sometimes they don't take very long at all. Oops, let's make this minus 4 so it comes out nice and easy. For example, this quadratic, I could take the 4 over, square root both sides, and it's the square root of a 4, so it's plus or minus 2. Okay, but I also want to show you this, x squared minus 4 is also a difference of squares if we wanted to think about factoring. X minus 2, x plus 2 is how it factors, and you can see you get the same two answers. So here we could do it with factoring. We could use the square root method. Well, I better stick to. So in this little example, I could use the square root method or the factoring method. It's also good to note that something like 5x squared plus 9 can be used in the quadratic formula. So let's show you how that would work. A is 5, B is 0, C is 9. So I'm just going to use the quadratic formula and I'm going to stick those in there. Negative of b, so negative of 0. B squared, that's 0 squared, which is still 0. All over 2 times a. So let's see if we get the same thing. Now, negative 0 is nothing. So this is just plus or minus the square root of negative, let's see here. That's 20 times 9, negative 180. You can see here, I'm going to have to poke an eye out. And this 180, I'm going to factor it. I think I'm going to factor it as 36 times 5. And I factored it that way because I can square root the 36, which is 6. And I can see that 6 over 10 simplifies to 3 over 5. Oops, get them both in there. And you can see I got the same answers as I did before, but that's using the quadratic formula. Remember, it always works. And then our very last one here, it's another one of these. This is just a special one. Notice how it's something in parentheses squared equals a constant. And these are nice because they're already mostly set up for a square root method. I have plus or minus root 5. I take my 8 over by subtracting it, and I put it in front of that plus or minus, and I divide by 3. Everybody divided by 3, which we usually just write this way. But you could also write that as individually divided by 3. Like that. So those are equivalent answers. Now, if you didn't want to use the square root method for this, you don't have to, but you would have to get it into standard form then. Distributing, 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 distributing. So 9x squared plus 48x, subtract 5, so it equals 0. So plus 59. Yeah. So then, after you got it into standard form, you could use the quadratic formula. There's your A, there's your B, there's your C, and you'd end up right back here. But you can see you have to do all that pre-work just to get to the point where you can use the quadratic formula. So it's much quicker to know the square root method in these special situations to be able to solve the quadratic. But again,